Hi there. We're going to evaluate the limit of 1 minus cosine x over x as x approaches 0. This is one of those classic limits you're just expected to know, and based on the graph, you might suspect that the limit as x approaches 0 is 0, and indeed it is. You'll love this. It's a real easy proof, but we will need two previous results that we have proven. We'll need the classic trigonometric identity for sine and cosine. Sine squared plus cosine squared equals 1, and we'll need this other familiar limit. The limit of sine x over x as x approaches 0 is 1. I'll leave links in the description to my lessons going over both of these results. Let's get into evaluating this limit, and we'll do our work in blue. For starters, we know we can't plug x equals 0 directly into the function because we would have 0 in the denominator, and we'd have 1 minus cosine of 0, which is 1 minus 1, so 0 in the numerator 2. We'd have 0 over 0. That's not going to work, so we'll need more sophisticated methods. This is one of those situations where multiplying by the conjugate is actually going to be really useful. The conjugate of 1 minus cosine x is just 1 plus cosine x. For a conjugate, you just have to flip the sign in the middle. We multiply the numerator and denominator by the conjugate so that we're just multiplying by 1 and there are no problems there. The reason you would think to multiply by the conjugate in the first place is that we've got 1 minus cosine x in the numerator. The conjugate can be useful when you would rather have the difference of the squares. So instead of 1 minus cosine x, I might prefer to have 1 squared, which is just 1, minus cosine squared. The reason I'd prefer that is that with 1 minus cosine squared, I'll be able to use the Pythagorean identity to make a substitution, and multiplying by the conjugate is going to get us there. This is calculus, so I'll assume you know how to multiply binomials and not belabor that point. I haven't simplified it at all. That's what you get when you multiply 1 minus cosine times 1 plus cosine. And what you see going on here in the middle, this is the magic of the conjugate, is we get cosine x minus cosine x. So those things cancel out, and what we'll just be left with is 1 minus cosine squared, so the difference of the squares, just like I said. In the denominator, of course, we've got x times 1 plus cosine x. Nothing too crazy there. Let's go ahead and simplify this. Like we said, cosine x minus cosine x cancels out, and we're left with 1 minus cosine squared of x divided by x times 1 plus cosine x. Now we can use the Pythagorean identity. We've got 1 minus cosine squared in the numerator. So how does that relate to the Pythagorean identity? Well, by this identity, we know that sine squared plus cosine squared is 1. So if we subtract cosine squared from both sides, we would have that 1 minus cosine squared of x is equal to sine squared is left on the other side. So we can replace 1 minus cosine squared with sine squared. We'll go ahead and scroll down a little bit. There is our substitution. 1 minus cosine squared becomes sine squared. Now to finish things off, we're going to split this limit into a product of limits. So we're using the limit product rule. We'll split it into the product of limits that we know. We'll take one factor of sine out along with the x in the denominator. That way we'll have sine x over x, and we know that limit. What's going to be left for the other limit is another factor of sine x, because remember it's sine squared, so we have 2 factors of sine x. So in the other limit, we'll have a factor of sine x, and then in the denominator, we'll have that 1 plus cosine x, and then we'll be home free. And there it is. We take out one factor of sine along with the x in the denominator, and then the other factor of sine is left with 1 plus cosine x in the denominator. This is the product of the limits, So all that's left is to evaluate these limits. Now, sine x over x, as x approaches 0, we know that limit is 1. Looks like I forgot to dot that I. Make sure I dot that. So sine x over x, that is 1 as x approaches 0. And then what about this guy? Sine x over 1 plus cosine x. That's continuous at x equals 0. We can just plug 0 into the function. So we've got 1 multiplied by sine of 0 is just 0. So in the numerator, we have 0. Denominator doesn't really matter that much, but we'll write it anyway. Cosine of 0 is 1, and so the denominator is 1 plus 1. This is just 1 times 0 over 2, which is, of course, 0. Again, these last few steps are just limit product rule. We take a factor of sine and the factor of x into their own limit, and we take the other factor of sine along with 1 plus cosine x into a separate limit. We evaluate those, and so our limit is the product of those limits. It's just 0. And so the limit of 1 minus cosine x over x as x approaches 0 is 0. Hope that was helpful. Let me know if you have any questions.